Yeah. So hello everyone, welcome. So last time we do saw do did some examples on relation and functions, but it was the general definition of function, whether the function is one or function is on two or function is into or something like that. We want to check about very important function, that is inverse trigonometric functions. So you might have heard trigonometric functions a lot many times, obviously, but this time we want to do inverse trigonometric functions because it is important to know it, and also able to solve some questions on it. So give me a minute, so I will just share my screen, and we are ready to go. I hope my screen is visible now. Yeah, so I hope my screen is visible and you are able to see my screen. So yeah, let's start our discussion. So as I said, we saw some examples on functions, but these are special types of functions. They are called inverse trigonometric function. Inverse trigonometric functions. What is inverse trigonometric functions? We know that a function is defined as a to b, where this is domain and this is range. What happens in inverse trigonometric function is function should be able to define like this. This becomes domain and this becomes range. So we are trying to say that if f of x is equal to y, then f inverse y is nothing but x. If the function is able to, I mean, we are able to define the function like this, then it become, then the inverse for the function is defined, we say it. And for the trigonometric functions, just like there are 6 trigonometric functions, similarly for each one there is one, and there are 6 trigonometric inverse functions also. So that is how we are going to define them. So if it is like sine x, f of x, so in this case f of x is going to be sine inverse x. That is how it is going to be, and so on up to tan and cot and everything up to cosec inverse x. So that is how it is going to be until cosec inverse x. Now what do we exactly mean by inverse? Let us say, what is the value of sine pi by 4 1 by root 2? Right, sine pi by 4 value is 1 by root 2, which means sine inverse of 1 by root 2 will be by 4. This is what I mean as if f of x is y, f inverse y, f inverse, the function inverse y is x. So x value is pi by 4 as it is, y value is 1 by root, but we should be able to define it, and in that case b becomes the domain. So in this case the domain becomes 1 by root 2 and the range becomes pi by 4. In our first function, what used to be, this used to be a domain and this used to be a range. This time this becomes domain, this becomes range. So I hope you have understood this conversion. We are just going to see what is the range and domain for the these functions as well. So yeah, so okay, let's see sine x. Let's see for sine x only, then we will go for sine inverse x as well. So yeah, something like that. Range is always on y-axis -1 to 1, and this is from minus pi by 2 to pi by 2, right? Maximum value is at pi by 2, minimum at -1, and maximum is 1. So in this case, value of x, that is a closed interval rather, minus pi by 2 becomes domain. What is the range? Range is indicated by r. What is the r? Minus 1 to 1 for sine. For sine inverse x, the graph exactly becomes opposite. So the graph is here is on x-axis. Here it becomes like this because the values, so here it will be minus 1 to 1 like this, and here it will be minus pi by 2 to pi by 2. I hope you are able to understand what I'm saying. Sine inverse of pi by 2 will be 1, so it will be like this, this graph will go like this. I hope you are able to understand it. So it is like this, it will be, graph will be like this. So if you want to draw the graph for sine inverse x, it will be on y-axis. I'll just draw one line, one cycle this way. This one is minus 1, minus pi by 2. This is pi by 2. Value for this will be minus 1. Value for this will be 1. Now you can see the change in these two graphs where the domain has become range and range has become domain. So for sine inverse x, what will be domain? Can you say? Domain will be from minus, I'm sorry, closed interval, minus 1 to 1. What will be the range? That is how the domain and range is defined for sine inverse x. What we saw here was sine x. What we are seeing right now is sine inverse x, and you can see how exactly this is becoming. As I said, as the definition, this is f of x is y, and you can exactly check in the this graph. This is f inverse y is x. You can check the difference, and this is what is called inverse trigonometric function, where the functions domain and range are reversed. I hope you have got it, and meanwhile you can subscribe to the channel also. Please subscribe to our channel because I know it will motivate us. Meanwhile, you can give the likes also to the video just to boost me. Yes. So and you can also type down your questions if you have, particularly if you have this question on inverse trigonometric functions, which is the topic we are saying. Yes, you can also drop your questions in the chat. I'll, as and when I get the time, I'll come back and answer those questions as well. You can ask the questions as well. Yes. Yes. I hope you are clear with the graphs of sine inverse x and sin x. Next, what we are going to do is we are going to see the domain and range of some functions. So yeah, so domain is easy, but let's see how do we remember the range for the functions. Actually, I'm going to give you a trick. How do you remember the range of not trigonometric? I'm going to give you a hint on range of inverse trigonometric functions. So this is the trick you will be using to remember what is the range. So 0, pi by 2, pi, and obviously we don't use here what we call 3 pi by 2 and all. We write this as anti-clockwise and clockwise we consider, so we write it as minus pi by 2 to. So that is how we term it. First of all, get one idea clear that no trigonometric function has range or domain in third quadrant. One thing you get it clear from your side, that no trigonometric function, either it be sine inverse, cos, or whatever it is, it does not have anything to do with third quadrant. Whatever the range, I mean we are saying range, whatever the range is now is all in first, second, or fourth. So you know that this is first, this is second, this is third, so nothing to do with third, and this is fourth. So I just marked it, but we don't need it now. Just remember that third quadrant, there is nothing to do with range and domain for inverse trigonometric functions. Now consider three functions. These functions go hand in hand. These functions, sine inverse x, tan inverse x, and cosec inverse x go hand in hand. In fact, there is one more correlation you will see subsequent in the class also. First is with range and another is with how we behave when the angle is minus. They also behave in the same way. We will see that as well. For right now, the range for this function inverse from minus pi by 2 pi. For sine inverse, you know what it is? Minus pi by 2 to pi by 2. We saw it in the graph. Now, how about tan? How to calculate for tan? You know that tan is not defined at pi by 2 or minus pi by 2, same thing. Tan pi by 2 is not defined, or we say it infinity also. So tan pi by 2 and minus pi by 2 are not defined. That is the reason it becomes open interval. There is a difference between sine inverse x domain and the tan inverse x domain. What is that difference? A sine inverse x is closed interval minus pi by 2 to pi by 2. What is the meaning of closed interval? X takes the value, or sine inverse x takes the value minus pi by 2 also and pi by 2 also. Tan inverse takes the value between minus pi by 2 to pi by 2, excluding minus pi by 2 and pi by 2. That is the important, the significance of the open and closed bracket. What about cosec inverse x? Now, if you see cosec is defined at all point except 0, right? Cosec is not defined at 0, right? Because what is cosec 0? Not defined, right? Because cosec 0 will become 1 by sine 0. Sine 0 is 0. 1, anything divided by any real number divided by 0. Not defined. So cosec inverse x is also defined on minus pi by 2 to pi by 2. No issues, but there should be no 0. Right? Or they write it like this also. Minus pi by 2 to 0, open interval, union 0 to pi by 2. It is one and the same thing. I am excluding 0 from this closed interval of minus pi by 2 to pi by 2. So these both are the same things. And you see, it is not difficult to remember range here. Sine inverse x has closed interval minus pi by 2 to pi by 2. Tan inverse x has open interval minus pi by 2 pi by 2. Now the cosec is obvious because it's not defined at 0. So let's exclude 0 from our interval, or effectively you can write like this also. There is no issue. This is our first group of 3. Group of 3. First group of 3. I'll keep it as it is. I will not clear the canvas here. Next. Yeah. Second group of 3. Second group of 3. Same thing again. As I said, there is nothing in the third quadrant. Forget it. This is 0. This is minus pi by 2. Similarly, this is pi by 2. This is pi as it is. First, second, third, fourth. There is nothing in the third quadrant as it is. So now we will remember what are the 3 functions remaining. Okay, for them the first and second is used. What are remaining? Cosec inverse is remaining, cot inverse is remaining, and sec inverse is also remaining. So I hope the sign is clear to you, and we will proceed to the next one, cosec inverse x and all. Obviously, cos inverse x is 0 to pi. Cos inverse x is 0 to pi, right? Similarly, sec. Now, if you see sec is not defined at pi by 2. So it is also closed interval 0 to pi, excluding pi by 2. This is open interval 0 to pi. I will take the detailed meaning. Cos inverse x, if you see, it is defined on 0 to pi. 0 to pi, closed interval. Cosec inverse 0 is defined, cosec inverse pi is defined. There is no problem with any of the function. Let's come to cot inverse x. Cot 0 is not defined. Cot 0 will become 1 by tan 0. It will become not defined. Tan pi is 0 again. So cot pi will become 1 by tan pi, which will become 1 upon 0, which is again not defined. So cot is not defined on 0 and pi, but all other functions it's defined. I mean, at all other points it is defined. So the range of cot inverse x becomes 0 to pi open interval. So if you see here, I have done one mistake while writing it. It should be open interval here as well. So pi is also not defined. Coming back to sec. Cos pi by 2 is 0. Yes, correct. Sec pi by 2 will be 1 upon cos pi by 2. Again 1 upon 0. Not defined. So all the things are revealing about 1 by 0 only, or 1 minus 1 by 0, something like that, which is not defined. So sec is not defined at pi by 2. So effectively people write it like that also. 0, okay, pi by 2 to open interval, pi by 2 to 0 closed union. So you can write it that way also, just like the last time also we written 0 to pi by 2 and pi by 2 to union. So 0 to pi by 2 open interval union, pi by 2 to pi closed interval. This is open. This has to be open. Lab cops. Just a minute. I'll write it again. Yeah. So pi by 2 to note that both are 0. We are just excluding at pi. If I have to write it in number line, it will be like this. It will be 0. This will be, let's say, pi by 2. This is pi. So this is nothing but like this range. Only thing here, the open circle, which means pi by 2 is not included in the interval. That's what it means. You know that, right? 1 to 2 means, how do we indicate on the number line? Open circles at 1 and 2, which means all the values between 1 and 2, but 1 and 2 is not included. Same thing here. So you can compare these two. It is the same scenario here also. I repeat, for sine inverse x, the range is minus pi by 2 to pi by 2. Tan inverse x, it is minus pi by 2 to pi by 2. Cosec inverse x, it is minus pi by 2 to pi by 2, excluding 0. It is not defined at 0. Excluding 0 because not defined at, yeah, so not defined at pi by 2. Here it is not defined at pi by 2. So sec inverse 0 to pi not defined at pi by 2. So we have excluded it. Cot is not defined at 0 and cot is not defined at pi. So we have an open interval for that. Cos inverse x is defined at all points including 0 and pi. So closed interval 0 to pi. Hope there is no confusion between range for the inverse trigonometric functions. I will also revise it again. Let's go to the domain. Domain is easy actually. For the sine inverse x, what is the domain? Again, minus 1 to 1. Right? What is cos inverse x? Same thing, right? Both will have same domain. What is tan inverse x? All values it can take. What is cot inverse x? All values again. What is sec inverse x? Minus 1 to 1 it is not defined, except minus 1 to 1 it is defined. So minus infinity to minus 1 union 1 to infinity, because minus 1 to 1 it does not take values, because minimum for sec is cosec inverse x. Same thing for cosec inverse x. Actually it is not difficult. Range, I mean domain is not difficult. The range we have to remember a lot. So the domain is not difficult. Domain is same as, you know, whatever the range is for sin x and cos x and tan x. So yeah, so the range for tan x is x equal belongs to our all values tan x takes. So all values tan inverse x also can have. So domain is not an issue. Range should have a trick, and I told you the trick already. Okay, let's go on to use some formulas now. Let's use some formulas. So again, the groupism is there. Sine, tan, and cosec has the groupism. First group, right? And this has the same outcome. This all the things have same outcome. Second group consists of cos inverse of. So when the angle is minus, so why I am telling you this? When the angle is minus, sec inverse x. When the angle is minus, it is pi minus cos, because it is defined from 0 to pi. Negative it does not come, right? Minus pi by, this is minus because it is anyways minus pi by 2 to pi by 2, open interval at least. But here what it is 0 to pi, it does not take negatives. So pi minus cot inverse x, pi minus sec inverse x. As I told you initially that apart from range, there is one more correlation of this groupism. So in this also they behave in the same way. So sine inverse of minus x is minus sine inverse x, tan inverse of minus x is minus tan inverse x, cosec inverse of minus x. So cosec inverse minus x is equal to minus cosec inverse x. So both the correlations are there. When the angle is negative, they also behave in the same way, and for the range also they are behaving the same way. Let's see some other formulas also. Sine inverse x plus cos inverse x is pi by 2. You might have got the hint what I am going to write now. It is going to be tan inverse plus cot inverse x is pi by 2. Sec inverse x plus cosec inverse x is also pi by 2. You might have got this hint when I wrote the first example. Similarly, as you know, sine square theta and cos square theta is 1. Similarly, inverse also we have some formulas like sine inverse x plus cos inverse x is pi by 2, and all other formulas also. There is one more formula, tan, most extremely used, most used formula in all of inverse trigonometric, when xy is less than 1. If xy is greater than 1, then you write it as pi minus tan inverse x plus y upon 1 minus xy. Xy is greater than 1. Tan inverse x minus tan inverse y will be tan inverse of x minus y upon 1 plus xy. So please remember these formulas, and you always find that there is some mistake when you are using these two formulas. So please always remember the condition x into y. For example, there is tan inverse 2 plus tan inverse 3. You will directly write tan inverse 2 plus 3 by 1 minus 2 into 3, which is wrong. No, why? Because xy is equal to 2 into 3 is greater than 6. No, this is 6, so greater than 1. So you will use the formula tan inverse x plus tan inverse y is equal to pi minus tan inverse 2 plus 3 upon 1 minus 2 into 3. So whatever it is, so you will write it as 6 by 5 or minus and then plus, whatever it is. You can simplify afterwards. The point is that whenever xy is greater than 1, you will use this formula. When xy is less than 1, you will use this formula. I will say that this is one of the most important formula and most widely used in all of trigonometry. All of trigonometry I'm talking about. So entire chapter you will find more than 50% of the time this formula is used. There is one more formula, tan inverse x in terms of 2 tan inverse x in terms of tan inverse, and 2 tan inverse in terms of sine inverse also. Not much difference. The formulas are in terms of cos. So for the cos it is 1 plus minus x square upon 1 plus x square. So the denominator is same everywhere. Yeah. So all these formulas are also important, which also means that you should be able to convert tan, 2 tan from 2 tan, 2 tan inverse into sine, 2 tan inverse into cos inverse also. We are going to see a couple of examples. One example is, if sine inverse x plus sine inverse y is equal to 2 pi by 3, then value of cos inverse x plus cos inverse y will be. So value of sine inverse x plus cos sine inverse y is given as 2 pi by 3. Then value of cos inverse x plus cos inverse y will be. Now you see sine inverse x plus sine inverse y is equal to 2 pi by 3. Now sine inverse x is nothing but pi by 2 minus cos inverse x. Pi, because sine inverse x plus cos inverse x is pi 2. And again, cos inverse sine inverse y plus cos inverse y will also be pi by 2. So this will be pi by 2 minus cos inverse y equal to 2 pi by 3. Now pi by 2 plus pi by 2 will become pi, minus cos inverse x minus cos inverse y is equals to 2 pi by 3. So pi minus cos inverse x plus cos inverse y is equal to 2 pi by 3. This will become pi minus 2 pi by 3. It will become cos inverse x plus cos inverse y. This is pi by 3 equal to cos inverse x plus cos inverse y. So you can check that value of cos inverse x plus cos inverse y is pi by 2. We simply use this formula, sine inverse x plus cos inverse y equal to pi by 2. Obviously, the angle is changed, just the formula will remain same. Yeah, let's go for the second example. Express sine inverse sin x plus cos x by root 2 in simplest form. Okay, how do you do this? Simplest form means what? We need to form some formula of sine and cancel this. That is what is the meaning of simplest form in inverse trigonometric function. The meaning of simplest form in inverse trigonometry is, if there is sine inverse x, make the angle in terms of sine and cancel that out. If it is cos out, make the angle in terms of cos inverse. If it is tan inverse outside, make the angle in terms of tan. That is what is the meaning of simplest form in inverse trigonometric functions. Simplest form has only one meaning. So now it is sine inverse x. We have to convert this into formula of sine. I know that sine of a plus b, sine a cos b, cos a sine b. I need to write it in terms of cos. Write it as cos pi by 4. Same thing, you can write it as sine pi by 4. Somebody will say, sir, why not here cos and here sine? Yeah, no problem, you can go ahead. Our aim is to find simplest form. Therefore, sine inverse outside means angle should be in terms of sine. That's why I can cancel sine inverse and sine. That is why I will use sine here cos and here sine. That is the reason. So sine x plus pi by 4. I can cancel this. This is x plus 5 by 4 in simplest form. So the converts into simplest form has only one meaning. I repeat, if it is sine inverse outside, inside it should become formula of sine. If it is tan out, then it should become tan inverse inside. So that tan of tan inverse also I can cancel. If it is like this, tan inverse of pi by 2, answer will only become pi by 2. So just for an example. So the reason we have written 1 by root 2 as cos pi by 4 first and then sin pi by 4 is simply that I want to form the formula in terms of sine, and then I'll cancel it and I'll get the simplest form. So I hope these examples were clear to you, and the domain and range, that is the most important thing. Domain and range was clear to you, and then there were some formulas which also we saw. So those formulas were also clear to you, and this was about domain, range, that these formulas. Again, here the groupism. And yes, hope this was some understanding to you. And yes, so you can also you can we are going to have two live sessions from this week onwards. We will hold one at Saturday 4 p.m. and Sunday 4 p.m. So we are going to increase, because as we know that for the CBSE the exams are declared, right? So the exams are declared and we would be conducting two live. Till now we would have one, but yes, and topics as and when we will be updating on the website, also on the Twitter, also LinkedIn, Instagram, everywhere we are there. You can follow anywhere, get the information anywhere. And also please be there at Saturday 4 p.m. and Sunday 4 p.m. as well. We do have live sessions for physics and chemistry as well. Just now at 3 p.m. we had photoelectric effect. So at 3 p.m. we had that. Right now 4 p.m. we have we had rather inverse trigonometric functions as well. So as and when we come to know what are the topics, we will inform you as well. So please be there on Saturday and Sunday, and please be there for physics and chemistry as well. If you have any questions, suggestions, please write it down in the chat box. This will be this way. Once the video goes on YouTube, you can write down in comments. We will be checking and replying you as soon as we see those comments. So thank you very much for the joining, and I hope this was very important topic. This is one of the important topic. And for JEE mains, if I am not wrong, 2014 it was for 4 marks, 2015 it was for 3 marks, last year it was for 2 marks, again last to last year it was for 3 marks. So minimum 2, maximum 4, that's how the range has been. But yes, two questions or 3 questions are that means that 2 or 3 questions will be there from inverse trigonometry in exams as well. And obviously for CBSE it will be for 4 marks anyways. JEE mains also you will have 2 questions compulsory on inverse trigonometry. So you can get instant tutoring also. You want live classes, apart from YouTube live, we also teach full course as well as on YouTube live or broadcast. It's not possible to practically complete the entire syllabus. You can get instant tutoring also. We do have tutors for physics, chemistry, biology, and maths. You may be from UK, Australia, India, any syllabus you have, you can always opt for live classes also. The website, it's mytutorsonline.org. You can go there, you can register yourself and ask for live class as well. And also right now, as the exams are declared, it is good decision to start the class. If you are lacking somewhere, it's good that you get instant tutoring also. You'll get instant tutors, you don't have to wait for weeks together, you will get tutors immediately. So yes, so thank you for joining. Have a nice day, have fun learning maths and other subjects as well. All the best. Good day.